standing at a position in an array where the left side sum and the right side sum are exactly equal. That a special position is called pivot indexes. And today we are going to solve the problem using prefix sum logics, one pass transversal and OFN, optimized solution and visual simulation and beginner friendly explanation. This question looks simple, but it's teach one of the most important interview concept, running sum. So let's master LeetCode question number 724, find pivot indexes. Hello everyone, welcome to my channel, myself Private. And on this channel we solve a coding interview problems and animation visual explanation, beginner friendly logics and optimized interview questions approaches. So whether you are preparing for practicing problem solving and LeetCode, you are absolutely in the right place. So, and if you are here new, make sure you subscribe because we upload coding content and regularly. That makes our community. So what's our problem statement here given? We are given an integer nums and our task is to find pivot indexes. Now what is pivot indexes? A pivot indexing is an indexing where left sum equal to a right sum. Important, the current element itself is not included in either side. So here given an example, nums equal to 1, 3, 6, 5, 6. Here output is 3, means the pivot index is 3, means left sum equal to nums 0 plus num 1 plus num 2 equal to 1 plus 7 plus 3 equal to 11, and the right sum is num 4 plus num 5, means 5 plus 6 is 11. If left sum equal to a right sum in the index is having a 3, means it's a output. Here given another example, nums equal to 1 2 3, but here no index gets satisfy the condition of the problem statement, so we return -1 at the end. Here given another example, nums equal to 2, 1, -1, means the pivot index is 0 because the sum equal to 0, no element to the left of the index is 0. So if right side sum is num1 plus num2 having 1 plus -1, means its answer is 0. So output is 0. Now to solve this question, what our approach to solve this question? Now for beginner often we brute force. For every indexes calculate left sum, then calculate left sum, but it takes O of n square because every indexes we transfer the array again, and normally it's not a optimized code. Now we're thinking like an optimized code. Now let's understand the smarter trick to solve this question. What if we already know the total sum of the array is, then the right sum can be calculated instantly. Then right equal to total sum minus current sum minus left sum. That means no repeated transversal, no nested loop, and only one pass needed. This reduces the complexity, means OF on. And main approach is normally first we find the total array sum, then initialize left equal to 0, then transfer the array, then right equal to total sum minus num side minus left. Means now we compare left equal to right. If having a equal one, then return the indexes. Otherwise we return -1. It's a simple and powerful logic to solve this question. Now we go to visually representation of this question. So it's we take an example one. First we generate array. Here we indexes 0 for 1, then indexed 1 having 7, then index 2 having 3, then index 3 having 6, then index 4 having 5, then index is having 6. Now we start from here. We start here. Now we pause. After here see that here index 0 having current number is 1 and the left sum is 0, but the right sum of the index 1 having the 27. It's not a status, means left one and right one is not equal. Then we go for further one. Here we go further one. Here we see that the second index is num1 is current number is 7. Means here 7. But left one sum is 1, but 7 right side one is sum is 20. Here left and right are not same. After we go further one index 2. Now here go to index 2. Here current value is 3. But left sum is 8. But right sum is of 3 is 17. Not equal to left and right sum. Then go with further index is 3. Here the left sum of this indexes is 3, but current value is 6. Left sum is 11 and right sum is 11. Means pivot is founded. Means pivot indexes is 3 to found that left sum equal to right sum. It's a visual solution of this question. Now we write the code. So here we write the code. We take an int variable sum equal to 0. After that we run and for loop. So we write for int n having the nums 1. So we write nums. Then we plus of nums when we write sum plus equal to the nth one to sum of the total one. So we write sum nth. After that we take and left int variable. So we write int left equal to 0. Then we run a for loop. So we write for int I equal to 0, then I less than nums dot size. It increment the I plus plus. Then we write int right side. For that we take variable right equal to, we write sum minus num I minus, we write num I, then minus the left one, then minus the left one. Then we take then we check if condition. If left equal to having right, means our according to question problem statement given having right, then return the index as pivot number. So we write right one, then we return I. After that we check left to one sum. So we write here left plus equal to the sum of the nums I we write. So we write nums I. Here is nums I. Here also nums. After that we return if not having left sum equal to right sum, then we return minus 1. So here we write, here we return minus 1. So the given example test case to check is code work or not. Here given example test cases are passed. Now we dry run the code. How it work? Has a visual simulation. We dry run the code. So here we take an example has 173, 6, 5, 6. Here having indexes 1, then having indexes 7, then 3, then 2, then 6. First we check from indexes 0. Then we check its right side sum and its left side sum. After we check indexes 1, it's having a right side sum, then left side sum. Then we check index 2, having to check left side sum, then right side sum. When having both left side sum and right side sum equal to, then pivot indexes is found. This is our answer. Now we check a visual simulation. Then first check left side, then right side sum, then left side sum, then right side sum. Then it's check if having a found that both sum are having, then it's a pivot number. It's a pivot index is found. Now we submit the code. Here total, all the test cases are passed. Here total 747 out of 747 test cases are passes to this question. So here to this question, the time complexity of this question is OF1 because we transfer the array once, and the space complexity of this question is OF1. No extra array is used, and it's fully optimized code. Why this approach is best? This approach is normally amazing because one transfers, no nested loop, no repeat simulation normally, and after that constant extra space means interview optimized code. This is classically prefix sum, running sum and array transfers. A common mistake normally do the beginner to solve this question is use nested loop, recalculated the sum repeatedly and includes current element in left and right sums. But our solution about all these mistakes is whenever you use question involving left sum and right sum, then balancing one, then sub array, immediately thinking about prefix sums, then running sum, then total optimization. This pattern appears very frequently, normally in problem solving. If this video helped you understand the pivot indexes clearly, hit the like button, subscribe for more DSI and LeetCode content, and comment the next problem you want to solve. If you enjoy this visual simulation explanation, make sure turn on the notification bell because we are building one of the best beginner friendly coding content. Thank you so much. Keep coding, keep learning, keep improving. See you in the next video. Thanks.